Hello, welcome to your next lesson on space, the Hertzsprung-Russell diagram today. First thing you need to do is go through and answer the do now questions in your booklet. So pause the video, when you've answered them come back and we will go through the answers. Okay, so first things first, let's go through the stages of a main sequence star similar to our Sun. Okay, so we're going to start with a nebula. And that goes into a protostar, main sequence star, a red giant, then we have a white dwarf, and then that turns into a black dwarf, okay? Okay, for a star with a mass much greater than our Sun, it's exactly the same, except for after main sequence, it turns into a red supergiant. Okay, then we get our supernova, which is where we get all our heavy elements formed. Anything heavier than iron is formed in a supernova. And then we've got our two options. Okay, we get our neutron star, or we get a black hole. Okay. Describe the forces acting on the star in the main sequence stage. Okay, so they are balanced, so the gas pressure caused by the heat from the nuclear reactions. We get gas pressure equals a gravitational force, okay? Okay, why does the star move from the main sequence to the red giant stage? Okay, it runs out of hydrogen. Okay, what element is fused by stars in the main sequence stage? Well, obviously that's hydrogen. Okay, and finally, at what stage are elements heavier than iron formed? Okay, and that is the supernova. Okay. So, our learning objectives are to interpret, describe and explain the Hertzsprung-Russell diagram of stellar evolution. Okay, so that's the life cycle of stars. We're going to respond to our core knowledge questions, describe the regions of the HR diagram and interpret the HR diagram. HR is just Hertzsprung-Russell, okay? So, where did it come from? Developed independently by these two scientists, okay? One in Norway and one in America. Okay, it's basically a scatter graph of brightness against surface temperature. Okay, but we don't use linear scales like you use usually in graphs. Okay, it's got a logarithmic scale, so it's a bit more difficult to read, but it does mean it doesn't take up a huge amount of space, and it does make sense once you get to that mathematical knowledge. Okay, they're given joint credit. And because they came up with it, they are called HR diagrams or Hertzsprung-Russell diagrams. Okay, so this is what it looks like. Okay, so across the bottom we've got our surface temperature. You'll notice this end is cooler than this end. Okay, so it's a reverse scale. All right, and up here we can see the brightness of the star. Okay, so this is sometimes called the absolute magnitude, and you may see that on different HR diagrams. Okay, so the brightness is here. We've got really dull stars and really bright stars, and there's our Sun there. Okay, bright stars have higher absolute magnitude, less bright stars have lower absolute magnitude. Okay, so we're going to have to label this. You need to do this in your booklet as well. Okay, so first up we have the Sun. Okay, so you'll need to use the drawing tool and the text boxes, so you just double click and put a text box in, you'll be able to label your HR diagram. Okay, so there's our Sun, and we can see that its temperature from this is somewhere around about 6,000, maybe 6,500 degrees Kelvin. Okay, 6,000 degrees, shouldn't say degrees, 6,000 Kelvin. Okay, so on to the next part. Okay, so this is the main sequence. Yeah, so they're the main sequence stars. Okay, so you can see that we've got ones all the way over here, extremely hot and extremely bright. okay, that are blue, and as we move down, temperature decreases, brightness decreases to our red end, okay? So we have all the different colours of stars right the way through there, okay? So what's next? When we think about main sequence stars, the next stage is red giant. Okay, so this is where our red giants are. Okay, so they've cooled down and they're a bit brighter. Okay. Next, we have our white dwarfs. Okay, so our white dwarf stars are just down here at the bottom. They're not very bright, okay, because they are cooling. Okay, and their temperature is also decreasing as well. Okay, so a white dwarf star will move from left to right and start moving down as well. Okay, so they've come from the red giant stage, so they'll do this. Okay, so the next part we're going to label is the red supergiants. Okay, so they are from our larger stars. Okay, they'll move up from the main sequence up to the red giant stage. Okay, so essentially we start off with main sequence stars, and they're going to move up to the red giant stage or the red supergiant stage, and then the red giants will then cool and move down to the white dwarf stage. Okay, so we start off in the main sequence, okay, and then we're going to move into the red giant at the red supergiant stage, and then the red giants will move down to the white dwarf stage, and the white dwarfs move across this way. Okay. All right, so what you need to do now in your booklets is you need to answer these questions, okay? So this is drawing back from your knowledge and understanding, your learning from all three lessons that you've had now on space, okay? So we can see here we start off talking about stars in general, okay? So you can go back and look at the previous lessons on stars if you need any help from there. Obviously, you can ask your teacher as well in the comment section underneath the assignment, okay? And also, these questions are from today's lesson, okay? So for these questions, 10, 11, 12, 13, you need to use the Hertzsprung-Russell diagram to answer the questions. I've put it here, but I've also put it in your booklet, okay? So make sure you've labelled your diagram correctly. Use the video to help you, okay? And then you have a past paper question here, okay? That you should be able to answer that really clearly. Write your text in the text boxes where it says answer. And then finally, in your booklet, you also have a blank HR diagram in which you need to draw arrows on the diagram to show how, show the path of the sun that it will take from the future. So it starts off where it started off in the diagram that I showed you. You need to draw the arrows, and then you're going to describe the changes in temperature and brightness of the sun throughout the life of the sun. Okay, so explain to me what happens. Use the scale on the Hertzsprung-Russell diagram. Okay, all right, and you can tell me what happens to the brightness and the surface temperature in the text boxes. Okay, all right, good luck with your work. Make sure you submit it before the end of the lesson, and any questions, write to your teacher. Thank you very much.